Yes, this is on. Okay. So, right, listen. This is for Earth and space science. The moon part, that's like kind of important. I'm doing this so I can study, but also now you can study. Sweet, right? It's a win-win. So, the moon, right? Let's just imagine this a picture-perfect image. This is the moon, right? It's very helpful. It benefits us a lot on our, like, green marble. Uh, I didn't mean to do that. Say this is Earth. I know the moon's smaller than Earth. I'm just, for the benefit, say this is smaller. Actually, I think I can make it smaller. That, that sucks, but it gets the point across. Basically, the Earth and the moon, right? The Earth has, like, water on it, and as the moon moves, the water gets pulled towards it because of gravity and tidal force. So you expect it to kind of look like this. This water's unaffected, right? But it's not. It's actually more of a rubber band effect. There's also the sun. The sun also pulls on the tides a little bit, like less than the moon slightly. But when they line up, which is either a solar eclipse or a lunar eclipse, which you know, that's when the tides are at their highest and when the moon, damn it, and God, when the moon is perpendicular, not no, yeah, perpendicular, that's the word. When they're perpendicular, it's the lowest tides possible. That's neat, right? So now you know how the tides work and how the moon kind of affects that. It's like marble chocolate chip cookie. But now that begs the question, what is a solar and lunar eclipse? I said that earlier. Like, what is that? So I'm going to explain that now. A solar eclipse is when the sun, our favorite star, hopefully, it's your favorite star because it's what's keeping us alive, and the Earth are it's when the sun and the moon are aligned in such a way that the basically there's much bigger distance. Basically, it's sort of like this, not like exactly halfway, but someone on Earth, right? Like this guy. This dude is gonna see differently. He's gonna see it like this. So, from his point of view, the sun is completely blocked out. This is a total solar eclipse. This is when everything's perfectly lined up, the sun being the exact distance away, that the moon being the sun being the exact distance away from the moon as it is larger, meaning that this moon can completely block out the sun from Earth. But most of the time we don't get that. Most of the time there's a bit of the sun peeking through. For example, this perspective, we can still see like this bit of the sun. That makes sense still. But what's a blood moon, right? Those are like creepy and spooky and everything like that. Like what causes that? Is that like a sign that the world is ending, that the moon's gonna explode? No, you're overreacting. Basically, add basically what it is that the Earth, basically it's taking revenge on the moon, where the Earth is blocking out the light from the moon. And you're probably wondering, why, how does that turn it red though? So basically, the sun emits a whole color spectrum like red, orange, yellow, green, blue, purple, all that stuff, and like the purple like be in the middle. Just like imagine everything else in between. But as you can see, the red's going around and it sort of curves in. The other light, though, is blocked, which turns the moon a seemingly bright red color. This is just how light works. Do something about it. And yeah, you use this to sort of. This is a lunar eclipse or a blood moon. Now, you're probably also wondering, like, sorry about that interruption there. Now, you're also probably wondering about how does this, like, why is this, like, brown gray rock orbiting our green rock? Like, what's that all about? So let's go back in time and let's introduce you to the Earth. I know, looks a bit different than what we're used to, but the Earth used to just be a ball of magma, basically. It wasn't actually a rocky planet. It was really hot and really bad. Everything sucked, and it was getting hit by meteors a lot. But one meteor wasn't a meteor. It was a planet called Theia. I'm gonna represent Theia like with this. This is Theia. Okay, say hello to Theia. Theia was just like a whole planet, slightly like big planet, right? And then they collided, and that led to boom, right? Now, the Earth must have been destroyed, right? No. The Earth survived, and Theia exploded. And this rock, now these like remnants of Theia are just like floating around us, condensing into us, and also condensing into themselves, making the moon. Now the moon formed very close, and over time it sort of floated away very slowly. It still is floating away, actually. It's very slow, though. You don't have to worry about the moon leaving. It's not gonna happen. So, now that we know how the moon formed, then the moon also helped because it sort of, that is the wrong tool. The moon also helped in pulling the magma, like pull and stuff, and water hit the earth in this time period also, and so did like all the oxygen and stuff, which made our atmosphere. I'm gonna make it the same color as the moon, but just know that there's the atmosphere. The atmosphere formed by all these rocks hitting, and one planet hit us and made the moon. So that's the history of the moon, I guess. It's just very simple. It's where's the clear button? You know what? I just realized I don't care. I just do this, right? Yeah. Now that's the moon. It's also now that you know most about the moon, time to learn about something that you can probably see with your own eyes and you don't have to use measurements or stuff for. Why does the moon sometimes look like this, and it's always depicted like this, when I look up in the sky, I can see this, but I can also see this, or like this. What's the deal with that? That is perspective. You see, the moon is something that's known as tidally locked, basically meaning that you are always seeing the same side of the moon. I'll color the, you know what the dark side of the moon is, right? That's the side that's not that's the side that's facing away from the sun, but not coloring in the dark side of the moon, just coloring in the half of the moon that we can't see. So basically, you see this, then as it rotates as it moves so that you only ever see this one side of the moon. Now, the sun the sun doesn't do that. The sun's just there. We're rotating around the sun. So, the dark side of the moon is the side of the moon that's facing away from the sun's rays, which, as you would see, doesn't always align with the side of the moon that we're seeing. So, if this is the dark side of the moon, so basically, if this is the dark side of the moon, and this is what we're seeing, and this is the part that we can't see. This is the only part that we can see, this little light gray spot here. This is what we can see. Now, from this current perspective, it looks like sort of like a pizza slice. But from Earth, we see that little pizza slice as this. This is what the moon looks like, and that's why it looks like that. Because we can see the part of it that isn't being lit up by the sun. That's why sometimes when you can't see the moon, it's because it's just in the way. That also means that a new moon can only occur when the moon is a new moon can only occur in a situation where the moon's sort of like here. But that's the same position as a solar eclipse, right? Clearly there's no correlation. No, there is. A solar eclipse can only happen during a new moon, and a full moon, that's when it's just on the opposite side. It's neat. That's the moon, I guess. That's just the history of our planet and, well, not our planet. That's next time. That's the history of our moon. Do with that what you will.